All right. Thank you all for joining with us today. So, in this session, I'm going to cover the introduction part. All right. Okay, so the agenda for this session is I'll talk a little bit about history and introduction, give you an introduction about blockchain, and then we'll discuss how blockchain works, and then I'll discuss a little bit about the applications of the blockchain technology, and it will be followed by an Q&A session. All right, so blockchain is a very popular topic today. But the interesting thing is, no one knows who invented the blockchain. This idea originated from a paper that was published around 9 years ago. Author of this paper was known as Satoshi Nakamoto. But we don't know yet this Satoshi Nakamoto represents a person or group of people or an organization. But blockchain technology is an ingenious invention. Once you get to know about this technology, you will understand why I am saying that it is an ingenious invention. So, what is a blockchain? As name indicates, it's a chain of blocks. These blocks can contain information. This information can be transaction or any other form of a digital asset. This chain of block continuously growing. There we can add many blocks to this chain of block. And also, this blockchain is secured using cryptography. There are some other interesting properties in blockchain as well. In a blockchain system, there are multiple participants. These participants will be able to see what's inside a blockchain. So blockchain is open to anyone in this system. And also, this blockchain is distributed amongst everyone. So we call it distributed. And also, there's no central authority controlling the system. It's decentralized. All right, so what is Bitcoin? I think Bitcoin is more popular than blockchain. So Bitcoin is actually none other than an application of the blockchain technology. We can simply call it Bitcoin blockchain. It's just an application of blockchain technology. Bitcoin is what it is today because of this underneath technology, power of this blockchain technology. So as you know, it's a cryptocurrency and a digital payment system. In this forum, actually, we are not going to cover the cryptocurrency. I just mentioned it to highlight the fact that it's a blockchain application. All right, so then let's discuss how blockchain works. Before that, I'd like to talk a little bit about hashing, because understanding about hashing is important to understand the concepts of the blockchain. In hashing, in this right-hand side, you have this piece of data, and you give this data to hashing algorithm as an input, and you will get an output. This output, we call the hash value of this data. We can consider it as a fingerprint for that data. If we change tiny bit of that data, the hashing algorithm will produce a completely different output. And hashing is irreversible. You cannot derive data from the fingerprint you have. But you can always validate the fingerprint by compute the hash of the data you have. All right. So earlier I mentioned that the blockchain can hold any sort of information. So transaction is one of the form that blockchain can hold. So in order to explain the blockchain technology, I'm going to use a blockchain system that store transaction information. So what is a transaction? Transaction is a cash flow between multiple parties. In here, you can see this Amarasri is trying to transfer 100 rupees to Premasiri. Let's assume this Amarasri wants to store this transaction information in a blockchain system. In order to do that, Amarasri needs to have access to this blockchain system. He needs to connect to this blockchain system. Let's assume Amarasri somehow get connected with this blockchain system. After that, he has to publish that transaction information to this system. Then let's see what happens after he published that information to a blockchain system. Blockchain system is actually a network that consists of multiple nodes. These nodes have same priority. So there are no master nodes kind of things. All of these nodes are equal. And these nodes form a peer-to-peer network. They communicate with each other using TCP protocols. And as you can see in this image, all the nodes have the copy of a blockchain. So they maintain the same copy of the blockchain. And we can connect new nodes to this system as well. Once a new node is connected to this network, it will communicate with the other nodes in the system, and it's also get a copy of the blockchain that system is operating on, and it stores that blockchain in his storage. Earlier I mentioned that that Amarasri guy published the transaction to this blockchain system. Let's see what happens in this network. These nodes are listening to the transaction information that is published to this network. So nodes validate these transactions published to this system. The invalidation process, nodes check the identity of the person who initiated the transaction, and also it check that person has enough account balance. These sort of validations happen there. After validating, these nodes try to create a new block by including this transaction information. Once a node creates a block, so we call that process mining. So we'll talk about that later. Once a new block is created, that particular node who has found that new block informs the other nodes in the system that it has found a new block. Then other nodes get to know that there's a new block found by some other node, and it will communicate with the node which has found that block, and it get with that block to their storage. And the other nodes also validate that new block can be added to their blockchain they have in local storage. If it is validated, the other nodes also add this new block to their blockchain. So all the nodes ultimately at the end have the same copy of a blockchain. So let's take a look at what sort of information there are inside the block. As I mentioned, transaction information has to be there inside a block. Other than that, there are some other important properties as well. One of those properties is the hash of the previous block. Earlier, I forgot to mention that once a node found a new block, it's compute the hash value for that particular block. So we call that signing a block. So this particular block, new block, need to have the hash value of the previous block as well. That's how it is become linked with the existing system. Other than that, block includes proof of work. The proof of work represent the nonce value. Represented by the nonce value here. We'll talk about that in a few seconds. All right, mining and proof of work. Earlier I mentioned that nodes include the transaction and create a new block that can be added to the system. In order to add a new block to the system, a node has to prove that it has done enough amount of work. Without doing enough amount of work, no one can add a block to the system. So we call that finding a new block, process of finding a new block, the mining. So nodes are actually miners who does that task. And how they can prove that they have done enough amount of work? It can be like consuming computational power, electricity, and etc. So let's see some sort of a, there are there are different mechanisms to implement this proof of work concept. So one of these is having a condition where the block hash should be start with n number of leading zeros. That means if you want to add a new block to a system, the hash of that block should start with, let's say, 4 leading zeros. You know that you cannot predict the hash value. In order to have a hash that's starting with 4 leading zeros, in order to find that hash, it is a difficult process. And also, let's take a look at what is block hash, how it is computed. Block hash is computed by including transaction information, hash of the previous block, and something called nonce value. As you can see, the transactions and the previous block hash, we cannot change those. But we can change the nonce value. So what a miner has to do is, it has to change that nonce value, and it needs to try to find a block that is having a block hash starting with 4 leading zeros. For example, it's actually random guess. For example, let's say miner has to start with nonce value as a 0. So it check the block hash and check whether it has 4 leading zeros. If it is not, it has to continuously do that process until it finds a correct nonce value that give you a hash that start with leading zeros. So finding that is difficult. So we call that a difficult target. So in order to add a new block to the system, you need to meet that criteria. So difficulty also can be adjusted over the time. It depends on the system. So this summarizes what we have discussed so far. The blockchain is a linked list of all the blocks that is created. So all the blocks has a link to a previous block. It includes all the transaction ever happened, and it includes the proof of work, and blocks can be validated by a node in the system. So you might be wondering that why we have that proof of work concepts, why we are like calculating the nonce value over time by using the computational power and electricity, etc. So once you take a look at the hacking, how hackers, if a hacker want to hack the system, for example, let's say hacker want to change the transaction in a blockchain. For example, in here, let's say someone want to change the transaction in block A. Once that guy change the transaction, what will happen? So definitely, the hash value of that block will change because something has changed there. So the new hash value will not meet that criteria because the new hash value has to start with 4 leading zeros. If we change the transaction value, hash value of that block, hash value of that block will not that criteria. So then that hacker need to find a nonce value, that nonce value which provide you the block hash that meets that criteria. So it has to do some work again. So after changing the transaction, it has to find that nonce value. It will take some time for him to find that nonce value. Let's say he finds the new nonce value after hacking that block. Is that enough? No. It is not enough because this block B also has a reference to the previous transaction, previous block. It has a previous block hash value. Because the hash value of this block is changed, this is also become invalidated. So you cannot add this new block to the system because it doesn't get validated. So you want to change the block B as well. You want to change the new nonce value for this block as well. And again, you have to find the new nonce value for this block C as well. So it is very expensive process because you have to spend some time, your computation power, electricity, etc. So cheating is expensive. It's cheaper to play by rules than to cheat. So that's why we have this concept in the blockchain. So as you know, it's been around for 9 years. No one has ever hacked the blockchain system so far. For example, Bitcoin is never hacked. So that's because of these underneath concepts it has in blockchain technology. All right, so let's talk a little bit about validation and consensus. Earlier I mentioned that once a transaction is published to the blockchain system, nodes are trying to create a new block. Actually, it's a race. Everybody is trying to do that. Every miner is trying to find a new block in the system. So there can be situations where multiple nodes simultaneously find the blocks that can be added to the system. So it's kind of a race condition. So there we need to have a way to synchronize all the nodes with the same copy of blockchain. So all the node has to agree on the same state of blockchain. So some sort of this kind of agreement is they have to agree on the longest chain on the system. So we'll discuss what happens if two nodes find 2 blocks that can be added to the current state of blockchain. In here, let's assume mining node 1 find a block that can be added to the current blockchain, and also mining node 2 find a blockchain that can be added to the current system. So they inform the other nodes in the system that there's a new block to be added to the system. Some of the nodes get that new block from node 1. Some of the nodes will get that new block from node 2. So for example, this block hash, the block with block hash LL will be added to the nodes who receive the node from the node 1. The block with block hash PP will be added to all the nodes all the nodes that receive that particular block. So both of these are valid blocks. It meets that difficulty criteria. Block hash start with 4 leading zeros. So there's no problem with accepting that because transactions are also valid, the block hash is so valid, so they update their version of blockchain by adding this new block. So we now have 2 versions of blockchain in the system. So we call that fork. And let's see what will happen over the time. So nodes operating on this particular blockchain will keep adding new block to its system. The other nodes will keep adding a new block to their system. So these these blocks in this particular blockchain cannot be added to the other one because it doesn't have the correct reference to the previous hash. Because this block hash YY cannot be added to this blockchain because it doesn't have the reference to the block hash PP. It has the previous block hash block LL. So for some time, there will be 2 versions of the blockchain in the system. Now, the nodes in the system will get to know that there are some other version blockchain in the system as well. So then we need to come to an agreement. Then the nodes who has the short version of the blockchain need to converge to the longest blockchain. So they have to ignore the blocks they have. Then they have to merge to the longest chain of the network. So that's how they come to an agreement on working on the same copy of a blockchain. All right, so let's talk a little bit about the application of blockchain technology. So blockchain initially became popular because of the Bitcoin. So it stores the transaction information. But people soon realized that blockchain can be used for other applications as well. So there were a lot of developments around it. People have started doing some researches, and it understood the value of the blockchain to be used in other different applications as well. So some of the platforms has been built based on these researchers and work. Some of them are Ethereum and Hyperledger. So these are some applications that you can, where you can use a blockchain. I think these topics will be covered in some later sessions as well. I'll just skim through these things. Some supply chain management, crowdfunding, sharing economy. These are some applications that you can use blockchain. I mentioned that there are a lot of platforms where you can go to if you want to develop blockchain-based application. So Ethereum is the most powerful one, as I believe, the popular one. So it's an open software platform based on the blockchain technology. It enables developers to develop their applications, blockchain application, and deploy in decentralized application in blockchain network. So, and also, it's based on proof of stake instead of proof of work. In the earlier, I mentioned about proof of work concepts. So there, all the miners, everyone tried to create a new block. So it's a kind of a waste because everyone is trying to create a block, but only one node will get a chance to add a new block to the system. In proof of stake system, it will be done in more deterministic manner. So the miner who is going to create a new block will be decided based on the wealth he has. So we call that proof of stake. Ethereum is the consistency of Ethereum is proof of stake, and Ethereum is specifically created and designed to support smart contract. And Ethereum comes with ecosystem for developers. So these are Ethereum ecosystem. I think these topics will be covered in later session. And let's talk a little bit about smart contracts. Smart contracts are similar to real world contracts, but it's completely digital. So it's a distributed ledger that stores contracts. So it can be used to exchange money, property, shares, or anything in value in a transparent and conflict-free way without having a service of a middleman. So you can think of it as some sort of a tiny computer program that has been developed and stored in a blockchain because the smart contract is stored in a blockchain. So let me explain the smart contracts. What is smart contracts using an example. I'll take crowdfunding as an example. In crowdfunding, so this product team, for example, a bunch of people come with a new idea. They want to fundraisers to support their project. So in order to do that, what happens usually is they go to this middleman, for example, Kickstarter. So in order to start this, for example, this startup, they have to find the enough amount of funding. So the supporters will fund to their project, and if that project group of team meets the enough funding, only they will be funded. Otherwise, if it didn't get the enough funds, the money that supporters has been funded need to be refunded back to the supporters. So usually all the supporters and product team has to trust a middleman in here, for example, Kickstarter. But we can avoid this middleman by using smart contracts. In here, you can develop a program as a smart contract and deploy that in blockchain. If product team gets enough funding, if it is meet that criteria, then only it will get the funding. Otherwise, if it doesn't meet the criteria, so over time, the funded money will be refunded back to the supporters. So this is some small example. So likewise, you can develop smart contracts using the Ethereum and other development platforms. Right. So from that, I'm going to conclude this introduction session. If you have questions on what we have discussed here, you can raise those. Yes. Yeah.
You were talking about the hashing algorithm.
Yeah.
So that is something like you have the source code, and it's the hashing algorithm you decrypt it or encrypt it.
Yeah. So
same way, should the receiving end also have that same hashing algorithm to decrypt the message and receive?
No, they are not going to decrypt the message. So they just validate that it has the correct hash. So they just check whether, for example, you get the hash of the new block, then you check whether it is valid. It's valid. It can be added to the system, something like that. You cannot decrypt the message. Yeah.
Other thing is, since you have replicates on same let's say you have a copy of the same original source. So in that case, it has to be a cloud enables blockchains. Blockchain has to be cloud enabled, isn't it?
So what do you mean by source? You mean like the?
No. Let's say before applying the hashing algorithm, you have let's say a document,
Yeah.
which a contract or whatever original contract that has been there, that is there, which has to be encrypted using the hashing algorithm and copied among the blockchain network, isn't it?
Yeah.
Yeah.
So
In
what's
that case, for us to have that, if we are to have that system, if you are to have have multiples of copies, is it necessary that we should have a cloud base? This has to be in the cloud.
It's not necessary to have in cloud.
If you have,
Yeah, sure. Okay. No more questions?
I just have a doubt on the proof of stake. I mean, you said it will choose the validator based on the wealth he has, right? Can you hear me?
Yeah, so I think you are asking about the proof of stake, right?
Yeah.
Ethereum. I think it will be discussed later as well.
Okay.
So what's your question?
My question is, what it matter for a newcomer? I mean, a person who doesn't have any ether with him. I mean, if I want to start mining, what it
So
mean for me?
there's something called gas. You need to have
Yeah.
some amount of that unit when you
So
start.
I need to buy it with by exchanging fiat currency, or
Not really. So when you connect to the Ethereum network, so you need to have something called gas.
Yeah.
So that part will be discussed, I think, in a later session in depth.
and that's fine.
If you're operating on proof of stake,
Yeah.
I mean, still there are no production level proof of stake networks.
Yeah.
But if you're operating on that, you have to have ether or whatever the currency with you. I mean, if you don't have it, you have to take it through your transaction. Or else you have to mine and earn it. So you should have a certain wealth with you for you to participate in mining.
Yeah. So
Yeah.
it's
So-
kind of a it will be little bias for the
Not really.
newcomers.
The concept behind it is basically if you have an interest on the network,
Yeah.
right, you would not cheat on the network.
Okay.
It's not worth for you to cheat on the network if you have your wealth there.
Okay.
So that's the underlying
Okay,
principle.
yeah.
So no one, I mean, people who have the wealth on the network would always work on making it, would work on sustaining it. Like, it would work on surviving it rather than destroying it.
Okay. So still, it's not in the Ethereum's live network, right?
Not in the live network as of my knowledge.
In any other test networks? Are they?
Test networks, of course, there are some beta
Yeah.
testing going on. I mean,
Yeah, okay, then fine. Yeah, fine. Okay, that's it.
So I think so that's all the questions we have. Do you have a question? Yeah.
Yeah, there you mentioned that you keep two temporary chains and you switch to the longest.
Yes.
So can you please explain what the purpose of that one and what happens if the shortest chain which you keep temporary contains some transaction
Yeah,
when
so
you switch to the
yes.
longest one?
Yeah, so good question. So she was asking about, I mentioned that the blockchain nodes that are operating on the short blockchain has to switch to the other one. So he's asking about what happens to the transactions that's been added to that particular blockchain. The thing is, so there's an agreement. So it's agreement that is defined by the system. You have to switch to the longest network because it has more blocks. But the transactions that were in that the other system will be also included in the other blockchain as well, because that blockchain has the blocks with same transaction. So we are not ignoring the transactions. The same transaction will be there in the other longest blockchain as well. It's actually validated because it's validated in the other blocks. Yeah, so these transactions, let's say you are going to switch to the longest chain. Then by doing that, you might be ignoring some of the blocks. These blocks may include transactions, but the same transactions are in the other longest chain as well, because the same transaction will be included in the blocks that has been added to that chain. So we are not really ignoring the transactions. We are just switching to the other network, other chain.
Yeah, okay, then again I have another problem. So when peers are, when nodes are validating the transactions, they validate the hash value. Then to take the hash value, they should have the original data. So does it mean every nodes have the original data to create the hash value?
No, actually, so they are trying to, when adding a new block to the system, they check whether the block hash is correct, whether it can be, it is meeting the difficulty criteria. And also, so that's the basic validation criteria, and this includes the transaction. So that's, I think that's what you're asking, right?
Yeah, maybe.
Okay.
Thank you.
She asked about that whenever the longest chain is, when extending the longest chain, the shortest chain, what happens to the transaction in the shortest chain. So you said they are automatically transferred here, but that is not the way it happens, isn't it? I mean, they goes to the UTXO, everything in the small chain goes to the...
So you are referring to Bitcoin as an example. So I just referred, for example, I think you are more like talking about UTX and all these things referring to the Bitcoin.
Yeah.
I'm just explaining using the general terms. So it has to be some sort of agreement. So the underneath technology and things can be different to the other blockchain networks. So I'm not taking as an example as an Bitcoin specific thing, just an agreement where if you face that kind of a situation, what sort of things you can do. If there's a race condition, if there are two versions, it's an example agreement that we can rely on.